Hey everyone, I'm a small lizard, and we continue for PnC with a third example where we're going to involve a certain technique that you may not expect to use. Every year, two teams, Europe and USA, meet for a competition. This competition is either won by Europe or USA each year and never a draw. If Europe wins in a year, the probability that Europe wins again in the following year is 0.7. If USA wins in a year, the probability that USA wins again in the following year is 0.4. USA won in 2015, so that is the context that we need to take note of, because that, as you will see later, will affect our calculations or our probability of finding Europe winning or USA winning. Alright, and this is actually found right here, where we know that we want to find the probability that Europe wins in 2018, so we're only concerned with 2016, 2017, and 2018, so only these 3 years. And you know that, well, each year, 2 possible outcomes, so by the multiplication principle, there are 4 total outcomes that you will get. Alternatively, you can just list them out. So you have Europe winning 3 times in a row after 2015, or UUE, thereafter EUE, and UEE. Alright, so you just need to find the probability of each outcome. So what I'm going to do is I'm going to list them up on the vertical column. Then, of course, this is not the right presentation. I'm just going to break it down like this so that we can easily calculate. Alright, so Europe winning after USA in 2016, that would be 0.6. Alright, so take note it's not 0.7 because the context is that USA won in 2015. Thereafter, Europe winning twice after that, so it's 0.7. USA winning twice after 2015, so that would be 0.4 square. Then Europe winning after USA has won is 0.6, again not 0.7. Europe winning after USA is 0.6. USA winning after Europe is 0.3. Alright, so take note because now USA wins after Europe, it will be 0.3, not 0.4. Europe winning after USA is back to 0.6. USA winning again after 2015, that would be 0.4. Europe winning after USA has won is 0.6. Thereafter, Europe winning again, that will be 0.7. Altogether, you add them up together, it would be 0.666, a very nice number. If USA wins in 2018, what's the probability that it will be their first win since 2015? Alright, so because we're looking at since 2015 and we want to find, and we know that USA wins in 2018, so that is the given probability, that's the given event. So we are looking at conditional probability right here because we assume that USA won in 2018. Which means that if you remember the formula, we are looking at P A intersect B over PB. Alright, so very simple, A intersect B, so we can think of it as A being the event that is our first win since 2015, and then B being the probability that USA, or rather being the event that USA wins in 2018. So we realize that there's only one case for USA to only win, have their first win since 2015, which is EEU. Alright, and that would be 0.6, 0.7, 0.3. Alright, not forgetting that USA won in 2015. So that is the intersection. And now we need to find the probability that USA wins in 2018. And there's a reason why it is part I, because remember in part I, we found the probability that Europe wins in 2018. So the probability that USA wins in 2018 would be 1 minus 0.666, right? The complement. And this would give us 0.3, I can't remember the number, so let me just check that again. 0.18 times 0.7 divided by 0.334. 0.37724, which should then give us 0.377. Alright, so with this, we move on to part 3. Alright, let me just draw a very crooked line down here. A team is said to have a winning streak when they win at least 2 consecutive competitions, so we're ignoring the fact that they can have a 1-year winning streak, right? So there's no such thing. If Europe wins in 2018, find the smallest nature K such that the probability that USA maintains a winning streak for in most K years after 2018 is at least 19.95%. Alright, so many things to take note of, right? First part is what we mentioned earlier, a winning streak is at least 2 consecutive competitions. So we're ignoring 1 year. And at most K years, alright? So a winning streak of at most K years, so we're looking at the probability where it could be 2 years, 3 years, 4 years, 5 years, and so on and so forth. So we are summing these probabilities together. All right, that's why it is at most k years, right? Because it could have a winning streak of 2 years, could have a winning streak of 3 years, and we're looking at the probability of everything, the cumulative probability of them having a win streak of k years. Okay, at least 19.95%, so don't be fooled, it is 0.1995, right? At least, so it must be bigger than or equals to 0.1995. So let's do some experimentation. Europe wins in 2018, all right? Now we have to find the number of time, or rather the win streak of USA. The first win probability is 0.3. Any subsequent win is 0.4, 0.4, so on and so forth. And you notice that we could kind of represent it as a general term of a geometric progression. Because the common ratio, you notice, is R, which is 0.4. The first term, quote unquote, is actually 0.3 in a way. All right. What you notice is that if it's a year, this is a second year win streak, this is a third year win streak, this is a fourth year win streak, and you notice you multiply 1 0.4 in the second year, 2 0.4s in the third year, 3 0.4s in the fourth year, you can realize that you can break it down to a general formula of 0.3 times 0.4 power k minus 1. Now, because the win streak only occurs at least for 2 years, the first term is 0.3 times 0.4. And then we have the third year, 0.3, 0.4 square, and then so on. And you notice that now we have a summation of a geometric progression. We have a geometric series now. And if we recall from the formula of a summation of a geometric progression, first term times 1 minus the ratio, with the power being in the number of terms. All right. So we want to sum until 0.3, 0.4 k minus 1. All right. So how many terms do we have? If you look at the original summation right here, if you look at this power of the ratio, 1 term, 2 terms. So you want to sum it until the k minus 1 term. So k minus 1 terms. All right. Over 1 minus 0.4, 1 minus r. Okay. Now this expression has to be greater than or equals to 0.1995. So bigger than 0.1995. All right. From here, we have 1 minus 0.4. Actually, there's no need for the square brackets anymore. 1 minus, let me just put it higher. 1 minus 0.4 k minus 1 bigger than equals to 0.9975. From here, we know that 0.4 k minus 1 is less than or equals to 0.0025. Now we take the ln on both sides, we get k minus 1. Because ln 0.4 is less than, or rather is negative, so when we divide throughout by ln 0.4, we have to flip the inequality sign. So ln 0.0025 divided by ln 0.4. K is then bigger than or equals to, let me just do some quick calculator punching, 6.5388, then you plus this one right here, so that will be 7.53, which is then bigger than equals to 8, because you want the smallest integer k, so it is bigger than equals to 8. Smallest integer is 8. All right, and you can kind of check your answer, all right, by simply, well, 0.3, 0.4 plus all the way to 0.3, 0.4 power 8. So you notice there are 8 terms. So you can just check your answer really quickly. 0.3 times 0.4 is the first term. 1 minus 0.4 power 8, or the power 8. Then 1 minus 0.4. And you kind of get the answer. Sorry, it's not power 8, it's power 7. Whoops, 8-year win streak, so it is power 7, yeah. So power 7 is correct. All right, if you try to get power 6, you realize you get a smaller answer, all right? You get 0.19918. All right, so that is how you can check your answer. And yes, this is how we can do it with the summation of GP. All right, so don't be surprised if you look at some formulas and like, hey, I can also apply it here, because, well, math is still math. Don't tie your methods to the chapter that you have learned. Instead, look at the methods and try to understand how you can use them, because it's possibly applicable at any scenario. All right, and I'll catch you guys in another video.